Okay, so we started talking about this CI/CD topic the last day, and I just want to pretty much finish it today, really, even though this week's lab and next week's lab will concern the same topic. And the only assignment, I was going to say the first assignment, the only assignment will be based on this area as well. That's probably for next week, really, if I put together a spec for you. So kind of essentially what CI/CD is. If we look at the DevOps kind of process, it's kind of the automation of all of this stuff here, automating as much as possible these parts of the DevOps process. Even if you're only working on a project on your own, because otherwise you have to kind of just do these things kind of manually, submitting commands from the command line manually. Uh, and so it's nice that when we just do a commit to our central repository, then that kicks off a whole process, automation process for us. But it's particularly useful when you've got a team of people working on a project. And I talked a lot about that yesterday. And so in terms of the kind of tooling that we use, there's lots of them out there. The one that we're going to use is GitLab. So if I fast forward to there, GitLab itself is a lot more than a CI/CD platform. It's what they refer to as a collaboration platform, and I spoke briefly about that yesterday. So we are actually only going to be using a tiny part of the GitLab uh, platform in this module. The language of CI/CD is pipelines, jobs, stages. We break our CI/CD process, or we sort of define it as a pipeline. That pipeline is broken up into stages. Where do I talk about that? Where do I mean? Oh yeah, here. Uh, we break our or we define our CI/CD process as a pipeline. A pipeline is made up of stages, and a stage is made up of jobs. That's a simple enough kind of architecture, if you like, or hierarchy. And the mechanics of it then are in the case of GitLab, we define this pipeline in a YAML file, and that's roughly where we left it off yesterday. And so this is the syntax. Most of the other CI/CD platforms that I've looked at, about maybe three or four, they all follow the same kind of idea of using YAML to describe your pipeline. The specifics of the YAML then varies from platform to platform. Although once you kind of study one of them, it's pretty easy to translate that knowledge to a different platform. So anyway, this is the very simple kind of 101 example of a pipeline in the GitLab context. So here are our stages. It's always going to be just a sequence of stages make up a pipeline. You don't have the sense of parallel stages. And then we define our jobs. But if you've got more than one job in a stage, then at runtime, those jobs are executed in parallel. So clearly, if there's kind of a dependency relationship between one job and another within a stage, you can indicate that, but by default, they're assumed to work in parallel, and there's no dependency relationship between them. As far as we're concerned, I guess is if you have a dependency relationship between two jobs, then those jobs should be in different stages rather than trying to describe the relationship, the dependency relationship, if they happen to be part of the same stage. The stage names can be anything you want to be. There are typical names, though. The jobs can be anything you want them to be. A job, then, like from a syntax point of view, well, sorry, from a construct point of view, I suppose we'd say, a job has a script associated with it, which we refer to as the build script, even though sometimes we build means something else in the context of CI/CD, so it has kind of multiple meanings. But in the context of this GitLab YAML file, anyway, the script part of a job is also referred to as the well, we can as the build script or just script more generally. These jobs are executed inside a container, and the scripts commands are executed uh, from the kind of command line within the container. So when we were talking about Docker and we did we executed the Docker exec command from the command line, if you remember, when we went, I don't have it there. If I go Docker exec, if I spell it correctly. So I've started up a container. Let's say it's our BusyBox container. And when I go Docker exec, specify the name of the container, and then hit return here, then as you'll remember, we're taken inside the container and we're at the kind of command prompt or the shell prompt for that container. And then we can execute any commands we want to. Now, that's essentially what you are getting here. What you put here are commands that are executed inside the container. Now, if you don't specify the image for that container, and a container, each job has its own container. If you don't specify the image for the container, and in most cases you would, but if you don't, then there is a default container that GitLab uses. But either way, these are just commands that are executed inside the container. Now, what I did not say yesterday is that um, the uh, the default location within the container that you're in when you execute these commands, like the default path name, path location that you're in, that path is created by GitLab and it essentially copies the entire contents of your project. Let's say this is the project that we're working on. Okay. It copies all of that into the container so that you have access to it from the command line here, from the script, if you like. And I'll prove that to you in a moment. Um, so that's the kind of the 101 of defining or declaring your uh, your pipeline. And by the way, the nature of YAML is you don't have to put these jobs in any particular order within the file. Uh, their their execution um, their execution is really controlled by the stages that you've defined and what stage you have said a job belongs to, which is what we're seeing here. Okay, so, but I guess it would make sense to put the jobs in some sort of logical order within the file, but that's just for us, the reader. GitLab uses the stage that a job is associated with, and where that stage appears in the pipeline list of stages, that's what it uses to control the order in which it executes all of these jobs. If I go back to VS Code, so here is my project Maria, even though there's no real application code in it except for this index.js, which is just a dummy file. Here's my pipeline. And I was saying there that So here's just a job, right? One of the jobs. And just for the heck of it, right, within the script of this job, I'm doing pwd. Pwd, as you know, is the Linux command for show me the name of the current uh, folder that I'm in, the current path that I'm located in. And then I do an ls minus a, show me the contents of this folder, right? So when I made that change and I pushed the change up to my GitLab repository, uh, here's the actual project repo up in GitLab. And if I now look at the pipeline execution, which yesterday I showed you that if you look at the this left-hand sidebar and go to the build part, where is build? Here. Again, it's a kind of another meaning for build, but anyway, if we mouse over the build part, then we can look at pipelines, jobs. So we can look at the execution of pipelines, the execution of individual jobs. So if I select pipelines, it's showing me here all of the execution of my pipelines that I've done. So I've done a couple of them. This is the most recent one that I've executed. And so when I showed you there in VS Code, I want to look at job A, and job A is part of stage one. And I want to see what do these two commands within the script of the job, what do they kind of output, or what's the response from them? And so if we mouse over the first stage and click on it, and it lists all of the jobs, of which there's only one. Now, if I click on this, which is really where I left off yesterday. What we're seeing now is the console output for the that was generated during the execution of that job. And here's the pwd command. So this path here, that was actually created by GitLab within my container for me. Yeah. You don't have to worry about that, but the path name is actually, it's taking this, it looks like it's taking this part here of the path from the name of the repository. It's taking this part from my username on GitLab, and then there's just a build folder. So this is a folder within the container. When I do ls-a of that folder, lo and behold, the contents of the folder is exactly the same as the contents of my project. So it has copied all of this stuff. Um, well, it hasn't copied it from my VS Code, obviously. It's copied it from the repository of the project itself. Yeah. So, so you have access to all of the contents of the file. Sorry, all of the contents of the project within the container, and that applies to every jobs container, irrespective of what image is being used. Now, if we go up a little bit, so there is like the start of this is all about kind of uh, creating the container and the kind of initialization of that container. And one part of the initialization is to load the container, load the image into the container, but I didn't specify any image. And by default, it looks as if it picks, where does it say it? Yeah, it picks a container that has the Ruby language installed on it. There's a kind of historical reason for that. I think when GitLab was written initially, the Ruby language was used to develop the actual GitLab website itself was written in Ruby. But other than that, there's no real um, significance to the default image that it's picking. Okay, back to my slides. Okay, I'm just showing you a screenshot there of what I've just been looking at, the way you can get access to the various executions of the pipeline. And we know from yesterday that the pipeline is executed whenever you do a push to the repository. Now, you can also kind of force a pipeline execution. If I go back to the pipelines kind of page, if you like, this one here, you can up here, like if you click that, and just go through one or two other clicks, you can force the execution of the pipeline again, even though there hasn't been a Git push uh, done to the repository. I've kind of already talked about this, so this screenshot is just showing you how you can look inside what happened when a container or when a job really executed. And that's what you would typically be doing when you're trying to debug. If some job exits prematurely, then you typically want to see what happened actually inside the container to try and debug it. And in that vein, if I go back to here, if I just force a failure of one of my jobs, by, let's say, if I enable this line here, okay, now that's just a kind of dummy force it to fail. And if I do a commit, just while that's working, if I check my local network, because okay, I'm on the set to red network, so just in case if it does go down, I have an alternative network to bring up. Hopefully it won't. Okay, back to GitLab. And if I refresh this page, okay, and we can see, so it has executed the first stage successfully. Now it's in the process of executing the second stage. That's what that kind of symbol means. And the third stage is currently kind of waiting to begin execution. So it's still executing the stage two, and we can actually, it is eventually failed actually, okay, and it won't go on to the third one. And so this is what you would typically do now. You try and find out, well, why did it fail? And we can see it was this job B, that failed. These two jobs ran in parallel. Okay, so job C ran successfully, but job B failed. And then we go into the console. This would be kind of the beginning of your um, kind of debugging process. And you try and find, usually you would get some sort of error message here. And the error message is generated whenever the particular command within the script of the job, uh, that command actually failed for whatever reason. In our case, simply because we forced it, you know, that's what the exit did. And here we've got the error message, which isn't really of any use to us right now. Uh, yeah, you can override obviously the default image that's used with the container, and this is where you do it within the jobs kind of specification. There's this image property, and you simply set it to the name of the image. And we're familiar with BusyBox, but this could be your image uh, or any image from Docker Hub or wherever, or some other container registry. And then it just simply GitLab will use that container as that image. Keep mixing up those words. It will use that image as the image for, in this case, jobs A's container, rather than the default image, which was that Ruby one. And the rest is as before. These commands now execute within our BusyBox imaged container. And I'm kind of proving it to you here because we can see when we look at the kind of startup of the container that it's actually using BusyBox. Where does it say it? It says it somewhere. Uh, Probably staring at me now and I can't find it. There it is there. It's referring to the actual BusyBox image. That's straightforward enough. You can have variables within your pipeline file, and specifically, you would use variables within the script of a job. Now, there are actually a number of different kind of levels of variables that are available to you. There are what are called predefined variables. So these are variables that are defined, they're kind of like global variables, I suppose. They're defined by the GitLab service itself, and it makes them available uh, to your jobs. There's a big long list of them. We use some of them within the lab for this week, but if you go to this URL here, you'll actually find all of the predefined variables, and I just did that before we started off this lecture. So if you just do a simple Google of GitLab variables, if you go to this link here, talks all about variables, but in terms of predefined ones, you can get the full list of predefined variables here. So there's lots and lots of them. These are all and they all begin with, I think they all begin with CI something. So that's predefined variables, and they can actually be useful, even though you might think they may not be. Uh, you can have simply local variables. That would be variables that are just local to a job. We don't tend to use those that often. You have pipeline variables. They are ones that you define at the kind of top of your YAML file, and they are available to every job within it. We do use those quite a lot. The last type then are what are referred to as environment variables. They are variables that tend to contain kind of sensitive data like uh, passwords or token values or that like, and you don't want to really put those into your YAML file. So, they can then be read by anybody really. So environment variables are certainly ones that we will use quite a lot. Now, the way you define an environment variable, if we go back to our so if you select it doesn't really matter where you are within the project. You don't have to be on the pipeline section. So if I actually go back to the repo part, now to define an environment variable, you go down to settings, and within settings, select CI/CD. you can see now here from just the variety of areas that are available to us within GitLab. There's so much to this GitLab um, service. But if you go to CI/CD and then you go to variables and then you go to CI/CD variables. So there's a heck of a lot going on here. Here's CI/CD variables. You add a variable and you fill out this kind of form essentially. Uh, and just be careful when you're filling out this form. I tell you exactly what should and should not be selected within these options. So it's important that you follow the lab instructions on that. And once you define those variables, then they kind of appear here. And you, whatever name, you can give the variable any name you want to. Um, where do you give the name? Oh yeah, the key, I suppose, the key variables are essentially key value pairs. So the key here means the name of the variable. And whatever name you give it, then you refer to it inside in your YAML file, and it's picked up at kind of runtime. Is there an example of that? Uh, well, before we look at environment variables, these are the kind of what we call pipeline variables, kind of variables that are accessible. They're specific to your pipeline. They're defined in this variables part, which typically, I'm not sure if it's mandatory that it has to be at the top of the file, but whatever names you give, it's up to you really. There is a convention, I'm not sure if it's stronger than a convention, that the names should be in capital letters and you can use underscore if it's a kind of multi-part name. So that's kind of a naming convention, but they're essentially just key value pairs. Yeah. Note now, this is not an array. You don't have the dash in front of them. So essentially variables is an object and the object is made up of just key value pairs. And then you refer to them within your script using this syntax here. Yeah, that's all fairly straightforward. This is a screenshot just from the environment variables part, which I've just kind of briefly demonstrated to you. So a job has, you specify the stage of a job, you specify the image for the job. The next thing is you specify this, what GitLab calls the services associated with that job. And services, what that allows you to do is to define other containers that will be available to your main script container. So essentially you can define a kind of a network of containers for a job. And you might think that's not something you'd use very often, but in fact, it is something that you use quite a lot, and we do it a lot in the lab. So a jobs script, often referred to as the build script, unfortunately, I think I'll just refer to it as the script because we're using this word build to mean too many different, have different meanings. But as I've just said, a job script, okay, it runs inside a container, but if you want to make other containers available to it, you define those other containers in this services part of the job kind of specification. And all you do in the services part is specify the image that you want that container to be loaded up with. There are a few other options available to you, but other than that, like you cannot specify a script for a services container. That's not possible. Um, Now, typically then, within the script of the job itself, if it wants to refer to that container, how does it refer to it? And this kind of goes back to all of the stuff that we were doing with Docker Desktop. and we had a network of containers. And how does one container refer to another container within its network? Well, in the case of GitLab, if let's say we've got a service container that has this image uh, running inside of it, and our script wants to refer to that container, then it simply uses the name of the image, right? If the name of the image happens to be something like this, then that's how you this is how you actually refer to that container within your jobs script. So it's an underscore wherever there's kind of a dash, a slash in the image name, you replace it with an underscore when you want to refer to that container. This is essentially kind of the domain name for the service containers. We talked about the domain names when we were looking at Docker itself, Docker Desktop. Here's a nice kind of simple 101 example. So here's my services section of my job specification, and I want my service to kick off a container that's running our good old Nginx image. Here's the script of the job itself, and because I specified, sorry, I've specified an image for my job as well. This image here, okay, we haven't seen it before, but this image is a kind of a bare bones uh, Linux image that has the curl command, the curl utility installed in it. Okay, so that's something we can get from Docker Hub. That means now that in this actual script, I can use the curl command if I want to, and I do in this case. If I do a curl of HTTP :// I'm actually sending a curl command to the web server that's running inside in this container. I could have specified port 80, but the default is port 80 for HTTP anyway. So when that command runs inside this script, the response down here will be the kind of home page for the default homepage for the Nginx web server. And you can try that yourselves if you want to. Just change any one of the jobs. Just put that exact job specification into any pipeline that you want to, and you'll see it working. I'm showing it, actually, I'm showing it down here, actually. This is the console log of this script. And you can see here when we did the curl command, what we got back, I'm just showing you an excerpt from it. What we got back is the home page of the Nginx web server. This is just some statistics on the response that came back. So that's this idea of services. Now, of particular interest to us is if we want our job script to run Docker commands. Well, first of all, that means that the image that our job uses has to have the Docker CLI installed in it. If I just rewind a little bit, at the very beginning of this module, we said Docker is a client-server architecture. There's kind of two parts to it. There's the client part and the server part. In the case of Docker Desktop, it contains both of them, right? It contains both the client side, which is just the CLI, and it contains the Docker daemon, which is the server side. And when we installed Docker Desktop, we kicked off the server, and then that meant in VS Code we could write Docker commands from the command line, and that was essentially talking to our local Docker daemon stroke Docker server. Now, how do we set up that kind of environment within a pipeline? Uh, and so this is one way of doing it. So I have a job. The image that I want to associate with this job is in an image that contains the Docker CLI. And you can kind of tell that from the name. Okay, it's something got to do with Docker, got CLI here, so that it's an image that's available to us from Docker Hub. That's fine. That means in the script part, I can execute Docker commands, but the Docker commands go looking for the Docker daemon or the Docker server. And that's where the services come in. In my services section, I am running a container that is running an image where the image contains an installation of the Docker server or the Docker daemon. And this is one such image. Uh, the DIND here stands for Docker in Docker. Okay, this is the CLI. This is the server or Docker in Docker. So these Docker commands within my script, they are communicating with the Docker server or Docker daemon that is running inside this container. I don't have to specify, I don't have to specify the domain name of this image because we're not talking about HTTP communication here as we were on the previous slide. Uh, so when I do Docker pull, that's really talking to the Docker server, and the Docker server then is talking to Docker Hub. That's what's kind of going on there. Docker images, that sends a request to the Docker server here, telling it what local images have you available to you. And it certainly would have this image here because we've just pulled it down, or the Docker server has pulled it down. So this is just a very one use case for this services, but there are many other use cases for it. The only reason I'm mentioning this one is because, we've done this kind of stuff earlier in this module. And there's an illustration here of what's happening within the script. Okay, what I'm showing you here are the full list of different parts of a job specification. Or am I? Well, I'm showing you some of them as well. Some of them are actually left out, but so far all we've seen is that in a job specification we can have a script. I suppose the assumption here is that the image part and the services part, they are part of a job specification as well. So they are left out of this screenshot here. But a job has a script, which we've seen. There's also, you can have a before script part. You'll see me using that in the lab actually. Now, the before script contains a list of commands, just like the script does. And the commands in the before script, they also run in the container associated with this job, not the services container now, just the main container. But obviously from the name, the commands within the before script, they execute before the commands within the script section. I guess that's fairly obvious. There's also an after script section, and same idea, you can put commands there. They run after the commands within the script one. I guess the only reason we have before script and after script is if the script section gets very long, then you try and break it up into like the kind of setup part, the tear down part, and then the main part of the script. That's the only reason we like to have these before and after sections. So if there's a sense that there is some sort of setup that you have to do within the script section before the main purpose of the script is, rather than having the setup commands within the script section, just stick them into a before script section. Similarly for the after script. The artifacts part of a specification, we don't actually use it, as it turns out, but it is very useful. And where it becomes useful is if you want, let's say one job generates some artifact, like let's say a zip file or a package, and you want to make that package available to another job within your pipeline, then what you do is you essentially specify that zip file or package, or more generically, that artifact. You specify it in the artifact section of the job that creates the artifact. And then other jobs can simply refer to that artifact, can access it within their own script. It'll automatically be made available to them by GitLab. We don't see it, as it turns out. We might see it later on, but we don't see it in this week's lab. I don't think we see it in next week's lab either. This part here is now redundant, and we'll see why in a second. You can also specify tags associated with, you can sort of tag a job. A tag is just a label, an alternative label. That might be useful if you had a pipeline that had quite a lot of jobs in it, maybe certainly dozens, if not more. And you maybe within the GitLab website, you only want to look at you only want to look at jobs with certain tags in them rather than having to page through all of them. The when property of a job, the only time you would use that is if you want to allow a person to control when a job should execute. And there are cases when that applies. Normally, jobs get executed automatically, and that's controlled by GitLab. But maybe there is a job within a pipeline, and when GitLab gets to the stage that it's now ready to execute that job, it doesn't actually do it. It freezes, it halts, or suspends the entire pipeline, and it waits for a person, a human, to come along and essentially click a button to say, you can now execute this job. And it executes that job, and any subsequent jobs after are executed automatically as well. Um, oh yeah, the next part of the syntax for a job is what are called rules, and rules allow you to. It's another kind of level of control that you have over when a job is executed. So far, the only way we can control when a job is executed is by putting it into a particular stage. But if you want more granular control, then you use this idea of rules. You add rules to your job specification. And this is the syntax of it here. And a rule is simply consists of an array of condition tests, if statements, in other words. And the if statement can have any condition test within it, whatever makes sense. Now, in this simple example, and this is one that we would use quite a lot, what we're seeing here in the condition test is we're checking to see, was the push to the repository, was it to the develop branch within the repository? The main branch is the branch called main. But let's supposing there were other branches within the repository, Git branches now this is, and the user has, let's say, pushed to one of those other branches. Here we're checking to see, did they actually do a push to the develop branch? If that condition is true, then yes, you should execute this job. If it's not true, skip this job entirely and move on to the next one in the pipeline. Yeah. So that's what this notion of rules. And rules really, if I go back to the previous slide, rules replaced uh, this thing called only or accept, which was the old way of controlling when a job should or should not be executed. So this part is now redundant. Here are some other examples of typical kind of rules that you might want to associate with a job. Um, we've seen the syntax for this one. Uh, was the commit part of a merge request? So there's a way of expressing that condition test. Was the commit a tagged commit? I don't know if you're familiar with tags or not. I actually show you how to do it in this week's lab. This has got nothing to do with tagging. Commit tags now has nothing got to do with GitLab. It's a feature of Git itself. But we know when we do a Git commit, we go Git commit and then we specify a message with that commit. Uh, when you've done that, you can also add a kind of a label to the commit, a label or a tag. They both mean the same thing. You can attach a tag to the most recent commit that you've performed. And the tag would tend to be some sort of string. Usually it may be a version number, 1.0, 2.5, kind of presumably indicating the version of the application itself that you're working on. And you can check, going back to GitLab, then you may only want a job to execute if the last commit that was performed to the repository was a tagged commit, as we call it. And I step you through doing that in this week's lab. You can either check whether the tag has a specific name to it or whether the tag has a kind of a pattern to it in terms of its naming. So in general, you can have an array of you can have an array of rules here, and they're all going to be if statements. And the way it works is if any one of these condition tests are true, then it executes the job. So it's a kind of an ORing rather than an ending of all of the condition tests here. This is the last slide. You'll be glad to hear. This is just a little kind of bit of background as to what's happening behind the scenes. So there are kind of two parts to this GitLab service. There's the actual website, and the website is what we are playing around with here. Yeah, so all this navigating around that we're doing, we're just really navigating around the website. But the actual execution of jobs and pipelines, they're all carried out on separate computers, or more generally nodes. And the nodes and computers that do the actual execute the actual pipelines, uh, they're actually contributed to by the open source community. Remember, GitLab now is an open source project. So any organization, even Setu, right, they could donate a node to the GitLab service. A node would tend to be a VM, really, a virtual machine, rather than a physical machine, an entire physical machine. Um, so you can contribute a node to the GitLab open source service. You can kind of register a node with them. And then the GitLab website uses those nodes to execute the actual jobs of a pipeline. So it's kind of a distributed network of nodes that's available to the GitLab service itself. And so there's this idea called GitLab runners. So these nodes, you have to have certain software installed on them, obviously enough. And the software specifically is you have to have the GitLab runner application. It's just an application that's running on one of these nodes. Down here, I say it's an agent, and that's essentially what it is. Because when the GitLab website wants to execute a pipeline, it will simply go through its catalog of nodes, and it will select one of them and say, "Can you execute this pipeline for me?" And the agent, the runner, will respond and say, "Yes, I can," or "No, I can't because I'm currently busy executing other pipelines." And if it accepts the request, then the GitLab website will communicate to the GitLab runner application running on this remote node. It'll pass the details down to it essentially, give it a reference to the repository, and the runner actually clones the repository and executes the pipelines, executes the pipeline within that repository. Specifically, the actual jobs themselves are executed by a component called the executor within the that's running on one of the remote nodes. So we've got the executor and the runner. That's kind of the back end architecture of this whole GitLab service. And then we have the website itself. So yeah, as I said, that's just by way of background. Although interestingly, the executor here, like I've said to ye that jobs run inside a container, but that's not the only option available to you. You might want a job to run on a VM, uh, or you might want a job to run uh, in a Kubernetes cluster. And so all of these other options are available to you. We've only looked at the case where our executors, if you like, wherever they are running jobs in a Docker environment. But we've got these other environments as well. Like VirtualBox, as you know, is a virtualization kind of hypervisor. PowerShell is obviously Windows um, runtime environment. So that's also available to Kubernetes. So it's really, really, it's a really, really nice service, this whole GitLab service. Right, enough talk. What I would like you to do now for the remaining time. How much time have we got? Okay, well, it took about an hour. That was all right. Um, I'd like you to work your way through this lab. Uh, but before you start it, actually, there's one thing. Like at the very beginning of this lab, I get you to create an empty repository up in GitLab. And people always make one mistake when they do that. So if I go over to GitLab and I want to create a new repository for myself, or a project as it calls it really. So I'll go click here. Let's try that again. And select plus. And I want to create a new project slash repository. I create a blank project. Now you give it a name, obviously. Now it defaults to setting the visibility to private. If you leave it as private, you cannot change it back to public after that. So make sure you make your repository public. That's number one. And number two, you also have to specify a namespace for the project slash repository. And if we select the drop-down menu here, select your username here. So I would select that. And then the rest is, you can leave the rest as it is, I think. Well, I would untick that as well. Now I do tell you about this in the lab, but it's always amazing how some people just don't pick up on it and they leave the repo as private. And then when they have an issue and they want to share the repository with me, I can't actually see the repository because it's tagged as private. And you, unlike GitHub, where in GitHub you can easily change a repo from being public to private and back and forth. Um, it's not at all straightforward doing that on GitLab. Not sure why they have this restriction, but anyway, it is. So just be careful about that at the beginning of this week's lab. Right. Are there any questions before I let you work on the lab? No? Okay, so have a go at,
Here, I have a question.
yeah, go ahead.
Uh, First off, in the submit instructions, for submitting it, the link at the bottom is broken. It's for a different subject it's for the old Agile one, not the current DevOps module in the submit. We don't have a submit link for this week.
Where is there a submit? There shouldn't be any submit, actually. Is there a submit?
Go and left, submit instructions.
Oh, uh,
Yeah, that's an old link.
no, I actually should have taken that out. I'm not requiring you to submit this at all, actually. Yeah,
Okay.
that's my mistake. Obviously,
Besides that, the other thing is there's a section on the left that has no title and it's a little hard to click on. I know it's there underneath the extend CI/CD. Uh,
that's two
it might
mistakes.
have been just a, it might have just been appearing small for the section right after. Yeah, see the pipeline there.
All right, yeah, okay, I'll fix that as well. That's good. Thanks for that, actually. Right, I'll fix both of those things. But if you're starting the lab, then I'll have them fixed really before you get down to those latter sections. Okay, thanks for that, and contact me on Slack if you're having any issues. Bye for now.